Before we add any more geometry, we need to save. All right, so save often, save oftener, as many times as you think. Trust the system. So I have created, I mentioned several times about Google Drive, and if you have the community college email or any Gmail account, you have space on Google Drive. I've also set up for and work with Dropbox. Microsoft 365 comes with OneDrive. Creative Cloud from Adobe has its files, but at some point it just gets to be too much. So if you want to look at Google Drive, this will install a syncing, so SYNC, sync, to connect your folders, your Windows folders, to the Drive folders. So if I needed these on another computer, I could log into my Drive account and then download them. So if I create a new folder for 2023 assignments, what did I call the other one? No, I guess I messed that up. So 2023, let's go 2023 spring assignments. So I started one to gather up my screenshots. So 2023 spring. Okay, so we'll go in there, and then this is my intro. To Solidworks part. So as an exercise, this is all informational. So create that, and then if I go over to, let's see, where would that be? On the My Drive, and make sure I'm in the right one. Oh, that wasn't it. There we go. So then it'll look something like that after I've brought it in. And because it is currently open, SolidWorks creates these little tilde, little squiggly line, $sign. Those are system files. You cannot open those. You may see those if you have your hidden files shown. Normally they are hidden. There are some reasons, and when we get to where SolidWorks dashes templates and sheet formats and that kind of stuff, we'll have to revisit that. Alright, so I've saved this. I can see a file name. There is no asterisk next to it. If there was an asterisk, I could glance up and see that I have not saved this file lately. It would also, if I have the save every so often turned on, it would pop up and say, oh, it hasn't been saved in 20 minutes. You might want to do that. Alright, so let's talk a little bit more about the contours and regions. I have pulled this sketch, and we can use this as a shared sketch. So if I expand out, and this is part of the navigation, is these little arrows and up and down arrows, being able to expand out the folders and see what's what. If I want to edit this sketch, then I'm going to right click on the sketch and edit sketch. I can also do that from the feature and edit the feature and then the sketch. And the other one here, edit sketch plane, would allow me to take this sketch from the front and put it on the top or the right, since that's pretty much all I have. We wouldn't want to suppress it, but we will talk about suppression states. And nothing really to roll back to. It would probably roll back in between the sketches, but this is our rollback bar. So if you ever happen, clear that out. If you ever happen to see the little pinching fingers grabbing the line, then that is the rollback. And if you move it it will warn you or ask you, and I didn't really want to there. So, but it is a technique to go back through the history and see the progression of a part. So it's being history based and parent-child features. Let's see. If I right-click, I have dynamic references visualization turned on for both the parent and the child. So if we click on one of these, I get these little arrows that point and say that is the immediate parent, and those are the parents of the feature and the sketch. There's no child at this point unless, nope, I'm not going to show it. All right, so if I create another piece of geometry, then I'll be able to see those child features. So our choice on this this geometry is if I wanted to put a hole through the part, then I could include that in the first sketch, but at some point it's going to be too complex to manage. So I can open up a sketch on a face. If I want a perpendicular face, then no way I can put it into that sketch and get a result. Let's go ahead and put it on that face. Open up a sketch. It rotates normal too. I'm going to hold off on the S key right now. That was my first instinct. And there's nothing really here to pick, but the arcs. I can look for the quadrants showing up as the little diamonds, the midpoint, the center, the midpoint. If I just go to the quadrants again, we can infer. If I kind of hover over these, I can see the midpoint. I can see an endpoint. Let's see if we can pick up a midpoint. Yeah, really not dragging, but there's one to that point. So just moving that around gives me some different geometries to look at. All right, so if I just draw a circle, this is underdefined, and we go in and now I create a cut. The advantage of the cut is I'm going to easily be able to say I want this 250 deep, and it will be 250 deep. Now if this were something that could go through, maybe I opened up a sketch over here and it could go through this, this, and this, then that is where the feature scope, the selected bodies, comes in. Most of the time we won't have to worry about those, and just like the contours, if you don't need them, you won't see them. It's just one of those, it's easy to overlook when it does occur when you do need them. So at this point, the reason that we turn off the instant 3D is this is very movable. We have arrows and sizing, and I want to say even the depth if I pick the right thing. And one of the strange things about the 3D sketch and cut extrudes and bosses, let's see if I pick that face, it is the one thing that will turn a cut extrude into a boss. So you do have to be careful with these. And that is one of the reasons that I just say go ahead and turn it off. You won't have to worry about the push-pull things coming up. It did change my dimension, which I don't like surprises. And the other thing that we would want to do so that it can't is we would want to apply relations. So if I put a smart image, notice that my origin shifted because I was dragging it around a little bit. No, the origin from the original sketch is over here. So if I go into the perimeter, then let's pause. Okay, so if I want to overcome the 3D sketch, we need to put a dimension on. I go to the perimeter of the circle for two reasons. It is easier to pick, and it also gives me the option to doing a max, the center, and a min. So if I come over here to the line is also an easy target. So I go 1 inch, and let's see, if I have to search for the center point, it's not terrible. It's just I can be anywhere on this circle and grab it. And we're going to take a quick look, so 0.5 at these two dimensions. So if I right click And let's see if it's there. And properties, no. Oh, there we go. Liters. And notice there is nothing down here. When I go to this one, it shifts over to the dimension I'm at, a min and a max. So the min would be that way. The max would be that way. And of course the center. Another one of those, you don't always need it, but it sure is handy when you do. And then for our dimensions, we looked a little bit at setting the liter types here. If I want it to be a radius, a diameter, and if I right click, we also in, I believe 2022, the service pack, we'll have to check the service pack because I'm not sure when this was added, but you can display as a radius and display as a diameter, display linear, and then we're doing the auto insert. I don't really trust anything that says auto, so I will look into that one again and check it out. Alright, so if I wanted to share a sketch, notice the difference between the two sketches. This one's contour and region, this one's a standard, I guess, region standard sketch. If I highlight that sketch and I go to extrude, it's going to return me to add geometry and pick the whole sketch. I don't really want the whole sketch. I'm going to pick that region, and then that's going to let me fill in. It would be the same as if I opened this up and did a cut and went some distance. Now if I merge the result, I'm going to go from 1, 2, 3 bodies to 2 bodies, this one and this one. If I don't merge the result, then I'll be adding a 4th. Okay, so that's kind of the confusing part of all of this with contours and regions. Let's put a number in. I'm not sure. Oh, and it's telling me 0 thickness even though I'm merging it. Interesting. So let's see what it's actually selecting. Still does not like the 0 thickness. So 0 thickness is still a bit of an issue. And I am making sure it's a boss. So very interesting that didn't build. So probably a little early to introduce the join, but if I tell it not to merge the result, or we change the feature scope, that would complete it, but it's still a little weird. All right, so if I change the feature scope, it should be at least able to connect to that one or to the other one. All right, so it's able to connect to that one. Still have 3. All right, so there's there's some logic and some potential issues there, but I don't want to get too far into that now. I like going down these rabbit holes and seeing where they lead, but not for an introduction. All right, the hole wizard. We have hole wizard, advanced holes, threads, and stud. I think the stud was added probably for 2023, so I don't think we're going to see that at all in 2022, but the others are here. So let's just stay with the hole wizard for now so that we can look at these geometries. And the first is going to be the hole type, and if we've set a favorite or a combination or some modification series, then we'll do that. That also reminds me of something else I forgot to do, but we'll go back one thing at a time. The counterbore, the countersink, the hole is the standard geometry, and tapped holes, a pipe tap or tapered pipe tap. Legacy is what's been around since I started in 97 or 98, so way back when. The counterbar slot was added a couple years ago, and the countersink slot, which is probably not as common, does have some uses. I've used the counterbore slot more than anything, and then just a standard slot, which is pretty much the same as coming up to the sketch and finding the slot or the operon. Alright, so let's just put a standard hole in so we can look at this. And if I filter for drill sizes, probably not a dowel hole. Let's just go to a fractional And we mentioned the 164 through, so let's pick a 930 seconds. If I don't know what 930 seconds is, I say show the decimal values. That puts us back into being able to see that's 281.25. Tolerances become critical when you're working in a group or even working on multiple parts. If I go through enough of these in different sizes, and I'm using the fractional, that if I have enough of these and I ignore the fourth and fifth decimal places over, say, 10 positions, then those will start to accumulate in sizes and vary my tolerance. We haven't looked at end conditions just yet. We sort of did a blind end condition on this cut, but the end condition says where's this going to end at. So if I always want this to go through the part, and we have two bodies here, so if I was over here and told to go this way, it would find, through all would find this, where up to next would find this back face. All right, so if I just make this a blind condition, then I have the same basic depth as that. If we stay with the up to next, it will find the very next item. And we haven't placed it, so it's still looking for the bodies and then our callout values. And I don't remember setting the document to that, but apparently I did something. So let's go into the positions. If you see the 3D sketch, please ignore it. Just come out and pick a face. And we'll place. And as long as we're in this point, it's everywhere we click is going to put a hole. So we need to escape. And we can either right click and go to the smart dimension, which very quickly we will be doing a lot of. And so I want this one half an inch off of the side and a quarter inch off the top, and we go ahead and accept. There it is. So if we're doing more complex geometry, you would see more, but this first sketch is always a point that locates, and the second sketch is the revolve that generates the geometry. Advantage here is that if I did this like this one and just made a hole of a certain depth, I don't get the drill point. So let's take a look at it first. And instead of the up to next, I'm going to give it a blind end condition of 0.5. And then we'll take another look at it. And so if I go to the front or to the side, let's see, there's the front. So let's just hit some arrow keys and rotate up, and I will go to my hidden lines. The cut extrude is going to be a flat bottom, and the hole wizard hole is going to have the drill tip included. Standard 118 degree, screw machine 135 degree, circuit board 100 or 120 degree, 140 degree. There's different sizes for different applications. So if you do the 118 and the 135 is a little bit flatter, and my CAM software sees that shoulder, it's going to go depth, and it'll be a little bit deeper. So advantage here is this one I would have to create those counterbores. This one I decide that the hole wizard, I want to switch this over to a counterbore. And typically for most industrial automation and projects nowadays, we're doing socketed cap screws, and we'll put in the same quarter inch. This is where those the major and minor diameters come in. If I show the custom sizing, on a normal clearance I have 266, which is about 8 thousandths per side, 0.2 millimeters per side. Size-wise, way oversize. We don't really need to cut it that big, so if we actually look at the size of these screws going to one of the vendors, we can see the head. We could put that down to probably 400, 406. Depth-wise, typically the socketed cap screw diameter is the same height as the head, or the height of the head is the same diameter as the screw. So we have a couple choices. I can either override the value there, or add a head clearance that I can go another 20 thousandths, which would make that 270 deep. And then if we go through all or up to next, that gives us the geometry. This side I don't really want it to be a counterbore. I can switch it to a countersink. And then I can also look at where it's going to overrun or interfere. Tap tool, decide that it wants to be a quarter 20. Shows me the tap drill. We calculated the tap drill for a quarter 20, and there's our 201. Also a through all. The limitation of taps, though, is 1 inch. I may only have an inch of threads to tap with on a standard spiral point tap. If it's not relieved or has other geometry, I may not be able to make it through. So you need to make the decision of, or be aware of, that I may want to have the threads, I may want the hole to go through, and have the threads, I need half an inch of thread to go with that geometry, or 3/8 of an inch, whatever. Alright, so advantage with the hole wizard is being able to go through and pick these and have access to those geometries. Alright, the memory that sparked, and I want to go back to, is early on I mentioned you don't want to be in the parameters. So let's just start a new sketch. We'll jump into that. And if I do the rectangle, then that is a click and drag rectangle. That is a click click rectangle. We get the geometries in there. And I pick one of these, and you see the parameters over here, and you think, I can put in a bunch of numbers. This is going to take significantly longer, and oops, the first time I move something, all of those numbers are going to change. Right, so I put in values here, and I want it to be 1.25 long. And I go to the trouble of telling it where to start, where to end, all of those geometries, and then I move it and everything changes. Right, we won't get that if we apply the dimensions. So also did not figure out why my sketch, so I have to look at that again. But again, we have contour, region, 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 contour. Right, so nothing says I have to create geometry. Interesting that disappeared. So are my sketches? Yeah, I'm viewing sketches. Oh, there they are. I lost it in the noise. So let's turn the shaded with edges on and take a look at how those are going to play out. All right. So one of the things that I'm going to be doing is whenever I open up a file, I don't see anything in front. There is no minus, there's no plus, no minus, no plus, no minus, no plus. Well, those two are shared. Oh, there's a minus. Something's going on there. If I open that up, again, these will move. These will change geometries, and depending on what these are used to create. So as an example, if I pull that out, and we can stay with the ½ inch, and not really looking to merge the result. That's another advantage of the solid bodies, that we can turn off the merge result. So we have that piece, and just enough of a gap, and go back and edit that sketch, and drag this way, and accept. We have an error. So if I show the problem is I changed the geometry and it says there are multiple disjointed closed and the intersecting contours. So it's not a big deal. It'll let us change those, or we go ahead and exit the sketch, edit the feature, and then in our contours we pick those. Alright, so I can make a pretty big mess of this pretty darn quick if I'm not paying attention to what all of these things are going on. So a lot of the problems starting out that you'll run into are just there's so much information and so many things going on that it is difficult to keep track of them all. work through it and get your geometry established. The first projects are not going for perfect. They're going for as much complete as you can get, and we'll build on that foundation to get better and better, more stable, more reliable geometry.